So, so requirements engineering, as I was saying, is a, full-fledged field. You need to go to customer. People call it gather requirements, but requirements are not, on the floor to gather them. You have to elicit them. You have to talk to human, and that led me to write actually a couple publications on how to elicit requirements better. English language is very ambiguous. You cannot really, or any language is ambiguous, and English is even more ambiguous. So you have to elicit requirements, and we use that construct called W5H. 5W questions and 1H questions to elicit requirements, but that even doesn't give you the full set. German has eight interrogative questions, and English has at least 7. So why we were using only 6? So a lot of thought went into in 2015, 16, we published 17, we published a bunch of papers, on that how it impacts the information systems if the requirements are not good. So the very first thing is basically the requirements engineering part. So once you have the requirements, that becomes your functional requirements. Then the other story is non-functional requirements are quality attributes of the system. So, definitely this is kind of a high level, how functional requirements can be broken down into a, use case model, and use case have to be specified, and, maybe sequence and interaction diagrams written, and they decide your system architecture. And then, when you, in traditional, software or, the vibe coding tools out there, you really cannot decide what kind of architecture at the system level you want. But our tool allows you with a click of a button it transforms your monolith into microservices or PubSub or even more. And it also keeps track of, atomicity of the data as well as the applications. So then all that leads into, your how you specify things that leads to the data model. So tools do not really allow people to pick up the data model. For example, Replit even doesn't do a, data model. Bolt and Cursor are, Bolt is not designed to be an enterprise grade system. So they really don't start with the data model. Data model is an afterthought. If you design any system with, these tools, you basically, they give you a Mickey Mouse or data in the memory, and, then you have to force them basically very hard to come up with some kind of data model, and they will not follow the modeling notation. So our software basically does the data modeling first, shows you the data model. Your data, your persistence requirements is of the most importance. Means, if you lose the cardinality, if you lose the integrity of your, stored data, your application is no good. So it starts with the, the data model, shows you all the abstractions of the data model. And then you can also decide, what kind of application microservices versus, PubSub or, monoliths you want to have. And then you write a code, right? And when you deploy it, your non-functional requirements, which you basically, there are about 26, there are 2 international standards, 26, 27, those abilities type, which people generally forget, and our software basically throws in front of you, you can pick and drop or add more. And then, those drive basically how you're going to deploy. And, deployment generally are separate teams. But the design team should have a say how my application will be deployed. Do I need a load balancer? Do I need to put them into how to separate the data, NoSQL versus SQL database, right? Sometimes it's an afterthought, right? So here it recommends you upfront, and then you can pick. So let's now dive into the application itself. So you can come here and type your prompt, and it'll start building for you, right? So we can do that. I have a pre-built project as well. So whatever is your choice. If you want to build something, we can prompt it out. It will give us a bunch of requirements which we are going to engineer, and then we're going to start building the system. I will let you choose which route you want to
go. Absolutely fine. Either way is absolutely fine for the purposes of this. I don't have an issue with either approach.
Okay.
Please proceed with whatever makes the most sense for you.
Okay, yeah. So there are some of the examples you can pick. You can prompt it, but when you prompt it, very first thing it gives you is, let me pick the project. I think let me pick any of these projects. Let me pick this. So it translates your intent into system terms, right? For example, if I come here and just say SSO, I want to add SSO. So system is smart enough to, pick up that the system shall provide single sign-on functionality to authenticate users. I can add that, right? So that's added into my, requirements. So then it recommends you a bunch of non-functional requirements, which you can, edit, change. For example, availability starts with 99.5. Also, order management should be 99.9% accuracy within 5 seconds, within the general, and also put some numbers looking at, what you're trying to do, 10,000 concurrent users. Some of the non-functional requirements it brings in it, and others you can add in. Then the very first thing is, it builds you, use case model. Here we go. So based on those requirements, it builds us the use case model, which can be later on specified. But here, you don't have to draw these models, by hand. What you can do is, for example, I want to say this user is basically the solution architect, right? So I can rename that. So here you can say the user is actor should be called IT, ARCHIT, architect. So you can rename, you can, assign, different use cases to different actors in natural language. And that is the case throughout the application, data models, application models, anything you see here, you can basically natural language, change them. And somehow it's not that slow even production. So it changed the name to IT architect. And for example, if I want, this use case to assign to that by natural language, say it, and it will bring it. So here you see some of the constraints. These are, your, the business rules you have put at the requirements level. They come into the use cases. And when those use cases are specified, here is the use case specification, usual, nothing new here, precondition, post conditions, and happy path and alternate scenarios. But, these are very important, things in today's world in AI coding. If you have your use cases done right, they become the basis of your UI. They become the basis how AI will code your UI. They, you can have a, style sheet done by prompting, I don't want blue color, I want that color. But the Bible of your system is basically your use case and their specification. Human must look at it, That's why, so it came up with these 17, use cases. You must go through them one by one, edit them. And once you are happy, you should basically, come up and draw your, if you want, some of those, the interaction diagrams you should, basically build, and you can, edit those diagrams. Yes. Now, if I want to make any change, let me turn it to white mode because black is not that visible. So I can make any change here, and I can, save that. I can manually change all my interactions. Then, this is what I was talking about, that when you have your system architecture done, recommended based on your requirements, based on your specifications, then you can basically change the design with the click of a button. So now that I have made some changes, it is, I shouldn't have made changes in the in the demo. I should have just shown directly. It is making those changes under the hood, and it will come up once it's done.
Makes sense. Yep, perfect.
And then I will go to the data models. And while it is doing that, data models, I think, are already there. You can see the green sign with them. So here's the conceptual data model. And, all those entities are defined. And here they are basically, their cardinality based on your requirements is decided. You can come up natural language, change them. You can if they are not legible, you can download, and you can download SVG, or you can download PNG. Some of the data models are hundreds of entities. But I can show you some previous versions of it. I think this was done yesterday. So this is how everything is going to look like into a document. This is your right now. It is saying some of the diagrams are being made. but whatsoever is made, let's have a look. So we started with these functional requirements. It came up with the non-functional requirements. It made this, because I selected black, if I have a white over there, it will bring the white image. But this is our use case model, and based on that, this is our interactions. All the use cases are there. All the specifications are in the document, and these are all the specifications. And let's go to the data model. The way you want to organize your system architecture is still coming up. It's not there. It will come in a second. Here is your data models. And here is, how you will deploy if you are deploying it on-prem. And I think it made, if you're deploying it on, different hyperscalers, it makes you that. So you can basically, now share this SAD with your governors. If you share the entire project, let's say if I put, a project contributor, so the whole project will be shared among my peers, which they can work together on the same document. But if I want to send it to the governors, I can pick, a different version, and I have to just send my governors, and governors will see if I send this to, let's say, info, or maybe that's ULTN. 2@gmail.com. So then, governors will only see this document. You don't have permission to share. Oh, why? This is weird. Maybe I'm logged in onto wrong, account. So, from here, you can share with your governors. As many governors as you put, they will be able to see your document. They will see only this document, and they can basically review and give you the comments on the document. You can export this document into, Microsoft Word or PDF, and share among your teams as well. So you can set up in the template how you want that template to look like when you export it. What I wanted to show you is, from here you click off a button and you can convert, that monolithic to microservices to PubSub architecture. And it does basically divide your data under the hood. So the whole, the difficulty is when you have, a data model working for a monolith application and you want to, convert it into microservices, how to basically make it atomic and how, to make sure that, the corporate level things work together means, there is a, let's say if you have to do a sidecar pattern so that, all your databases are connected. So it recommends you all those things. Somehow it's either it's a long, or maybe there are a bunch of people using it, so it's a little slow for me. I have to wait for it. But this is the whole idea, right? I'll for sake of time, it's almost 24 minutes. Let's take a few questions if you have any before Dave leaves us, right?
Okay. That is possibly the most comprehensive demonstration I've seen of that kind of tool. In under 20 minutes.
Thank you.
You've covered absolutely everything that I was looking for in terms of the flow, the outputs, the inputs, the documentation side, the range of diagrammatic representations of the architecture at the varying levels, the granularity that I've been able to see from in here. And don't worry about Mermaid, okay? Sometimes Mermaid, there it is. Sometimes Mermaid can take its sweet time. I've had lots of fun with Mermaid in the last few weeks. This is absolutely comprehensive in terms of a holistic architectural overview and oversight. At the moment, to achieve 1/3 of what you've shown me here today, I'm currently using about 6 different pieces of software. And I'm still struggling to try to get the traceability back through the stack. And the business problem. If one of the artifacts changes, then you have to go back through the entire strata of information and then do manual updates, which of course is tedious. The thing I think that I like about this is, apart from the obvious use of natural language prompts, the attention to detail, particularly on the non-functional requirements, is particularly refreshing. Most of the time, half of the tools out there only look at functional requirements, and even then, the level of granularity they extend to when you get further down the stack is normally extremely high level, and the orchestration of the information is not succinct. So honestly, this is very, very refreshing, and I would absolutely love to be able to do a bit of a deeper dive onto this at another juncture.